Hey everyone, welcome to another episode of FabForge 5. We design and build fun and unusual things, and we always learn something new along the way. I'm glad you're here. We're going to start building part 2 of our Spaceship in a Bottle project. In part 1, we took our special space capsule shaped bottle, built a bottle cutter, and cut the bottom off so we can fit our spaceship inside it. Now for part 2, we're going to do some electronics work. So we'll start by firing up our little vintage miniature CRT here, and we'll put a space-themed video on it that our astronaut will be watching while they are flying our spacecraft. And then we'll also build a special flickering engine nozzle electronic out of a 3D printed engine nozzle array and a circuit playground express from Adafruit. We'll have some fun with this. We'll see what we can do. Build some cool stuff. Glad you're here. Let's get started.
FabForge 5.
All right, let's figure out our mini CRT and see if we can get this thing working. So these were made for camcorders back in the 90s. This specific one, I think, is like vintage 1995. So they're literally a cathode ray tube display. So here's a display in the front, and you can see all the electronics in the back. Now what happens here with typical cathode ray tubes is they get powered, in this case, by 5 to 6 volts. There's a high voltage transformer inside here that creates around 1,000 volts that drives the electron gun in the back of the cathode ray tube. So this is a big glass tube that has a vacuum inside it. It shoots a beam of electrons up to this screen that has a phosphor coating on the inside. And when that beam of electrons hits that screen, the phosphor glows. So that's how you see a display in a cathode ray tube. Now it's got a bunch of little coils here all around the vacuum tube, and those coils get energized and they deflect the electron beam, so they control it this way. So the beam basically creates a raster. It goes across as if you're reading a page and goes down, starts again, goes up, goes down very quickly. That beam is controlled by the magnet coils here. And then it creates, of course, a display on the phosphor tube in the front. Classic CRT. So again, these are made back in the mid-90s. You can find them in really old, vintage camcorders. They started making these, I think, around in the early 90s. There are different models of them. Here's another one that's pretty similar. They kind of progressed through the years, as you can tell, because the PCB that controls them got a little bit simpler and smaller usually. Now, once the manufacturers got around to the late 90s, they changed, and for the viewfinders for camcorders, they started using liquid crystal displays. Not quite as exciting. Now, the problem with liquid crystal displays is that they have many connections that plug into a control board within the camcorder, and that usually connects to some kind of a graphics chip that drives the liquid crystal display. So it's nearly impossible to interface with these and make a display on that. But the nice thing about these vintage CRTs is they only have 4 inputs. So they usually have this little ribbon cable. It's really fragile, and they plug into a very small connector right there, but only 4 pins you can see there. So those 4 pins are almost always the positive voltage, which in our case we can use 5 volts, a ground, the video input, which in this case is the yellow wire, and then another ground, which actually lights up a small indicator LED here on the front of the printed circuit board. That LED usually has some kind of a light pipe that goes up to the viewfinder, and I think they were usually used to tell people if they were actually recording or not. And so we get kind of a free LED for that. Now that turns on actually if you ground it. That's a little bit the opposite of what you would think, but since we get a free LED, we'll just ground that pin and we'll get a nice little LED lit up inside our display. So this is what we'll use for the command console for our astronaut inside our spaceship in a bottle. But we obviously want to put some kind of a video on our little CRT here. So we need to be able to enter a video signal onto our yellow wire here. Now, what these expect is a composite video signal. And that's the video signal that you get from the classic old RCA connector. So here's one that has, you know, the two audio channels and then a video channel. So it's that connector right there. Not many things have this anymore. My laptop doesn't have it. DVD players always have HDMI now. They're kind of hard to find outputs that actually output that old style composite video. You can find something like an old Roku that has composite video output. You might have a DVD player that has it, but we need something that outputs that style of video so we can turn on our CRT. Now it turns out we can do that with the Raspberry Pi. So here's one of the original Raspberry Pis. So it has two different types of video output, the HDMI and our good old fashioned composite video. Now the newer Raspberry Pis, they actually take this composite video and combine it in the audio plug here and just add another ring in that plug. But it's still there. We could still use that in an older Raspberry Pi or a new Raspberry Pi. So that's one way we can do this. Now, another way we can do this is with a newer Raspberry Pi. So this is a Raspberry Pi Zero. It's a really small Raspberry Pi. It's actually the cheapest Raspberry Pi. You can get these for a few dollars. So it has a couple of benefits for us. So first, it does have a mini HDMI output for video, but it also has a composite video output, but you can see there's no jack on here for that. It's actually kind of hidden, and it's here in a little pin called TV, and it's a little bit kind of hard to show you on my camera, but there's a pin right there called TV. So TV is the composite video output. It's got the video and a ground right next to it. So if we connect to those, we can output from our Raspberry Pi Zero. Now the Raspberry Pis are pretty smart. It detects what type of display you have connected to it, and it auto selects that output. So if you have it plugged into an HDMI, it will always default to the HDMI. If there's no HDMI and there is a composite video connected, it will output to that. So we should be able to use our Raspberry Pi to drive our mini CRT. And by the way, here's a quick diagram of how I figured out the pinout of this mini CRT. I actually was able to get a data sheet from Sony that showed that. And it turns out that almost all of these CRTs that you find use that same pinout. So that's how I was able to figure that out. Now, for some reason, you couldn't find a technical diagram that showed you the exact pinout. And if yours varied from this, what you can usually do is figure out by process of elimination. So if you look on this PCB, the largest traces are usually the ground traces. And then you just kind of experiment from there. You connect a wire to the ground trace, then you start connecting or probing with a 5-volt wire to the other 3 inputs on your plug. You'll notice right away when you hit the right input, you'll kind of hear the high voltage power up, that kind of high pitched sound, and you'll see the display turn on. And then the other 2 are just figuring out how to turn on the little LED, etc. So that's kind of how that works. All right, so we'll take this small CRT and we'll connect it to our Raspberry Pi and see if we can power it up. Now what I've done, I took a connector off of a broken CRT, unsoldered it from the board, and used that as my connector for my wires. Now you'll notice these are really small. The pins are small. You need a pretty good soldering iron with a very sharp point to solder onto this. But just take your time and it should work just fine. So we'll see if we can get this hooked up and connected. So here's the pinout for our Raspberry Pi. You can see that we've got 5-volt output, a ground, and then of course we have our video outputs on our second ground. So let's connect things up. So here's the 5 volts to power our CRT. Here's the ground. Another ground. And there's our video input right there. All right. It's as simple as that. Actually, can't get any simpler. So now we'll turn on our Raspberry Pi, and we should see our CRT power up. But I'll hold it closer to the camera once I get this plugged in. I only have 2 hands today. Now, when you're touching a CRT, there you go, it's powering up. So that's our Raspberry Pi startup script right there. So it is working. Now, just be careful of this. This CRT has, like I said, 1,000 volts in it, at least, that's driving the electron gun. Be careful where you touch. It's in this area right here that's enclosed with, what would you call it, the metal enclosure. And then it's also in the area in the back of the electron gun, the vacuum tube. So hold it in the right place. Just be careful what you're doing. But there our CRT, or Raspberry Pi, is starting up. Now, it's going to run for a bit, and then it's going to start, we hope, our space-themed video. And here goes our video launcher. Give it a bit of time. And there we go. So it is working. Pretty cool. Now, I'm going to do a separate YouTube video on electronics for artists. I'll go into a lot more detail about how to use a Raspberry Pi and other electronics for art installations. But if you have an art installation, or maybe an exhibit somewhere in a museum or a gallery, and you need to do some kind of video or audio, Raspberry Pis are great for that. You can make them loop a video over and over again. They output an HDMI. They're high resolution, high quality audio and video. They just work really well. So watch for a second video about that. Now, to run this video looper on Raspberry Pi, I used a great tutorial from Adafruit. I'll put the link in the description below. It's a video looper program that loads onto a Raspberry Pi, and then you actually load the videos onto the same SD card that runs your Raspberry Pi. And so that card's right here. If you haven't used a Raspberry Pi before, it basically uses an SD card as its memory and hard drive, essentially. So everything that runs the Raspberry Pi, its programs, its operating system, and its files go on an SD card just like that. And so in our case, for our video looper program, we load that program on following the tutorial, and then we load our videos onto the same SD card. It will find those videos if we put them in the right file folder, and it will just loop through those videos. I think I've got about 7 or 8 videos on here. So it just runs through that loop, then starts over again from the beginning. So I highly recommend using that tutorial from Adafruit. It's really helpful. And like I said, you can use Raspberry Pis for all kinds of displays, art installations, etc. They work fantastic for that. But here's our kind of space-themed video here. So this is what will fit inside our Spaceship in a Bottle. This is what the astronaut will be looking at as he flies his spaceship. So you get the idea. So it works pretty well. Now, when you buy these, if you do, you can usually find them on eBay, usually part of a old camcorder, or sometimes people just sell the viewfinder on its own. You can get them for, I don't know, $20, $25. They're getting really hard to find now, though. There's just not many of them around. But look for a viewfinder that looks kind of like this. If you find one that looks more like this, it's probably smaller, and it's probably one of the LCDs that's not going to really work for you. So just keep that in mind. But you can see it works pretty well. This has some pretty good resolution. I do like it. Now, there are adjustments. So these small wheels that look like little gears are actually adjustments to adjust the magnets and the coils to deflect the electron beam. You can see they have glue on them that came from the factory. So this was adjusted at the factory to be really nicely dialed in. You can change these if you want, if you feel like it's out of adjustment. I've tried that before and I've only made it worse. So you might want to just stick with the way it is. That's probably the way it works best. But you get the idea. It does work. And you can see the little stars there in the star field. It's got a pretty good resolution. These things work really well. I love these things. I just love this kind of vintage electronics. So this is what will be kind of the heart of our spaceship in a bottle. All right, now let's take a look next at how we light up our engine nozzles. We want to simulate an engine running with some different colors and stuff. We'll use a different type of electronics for that. So we'll take a look at that next. All right, now we're going to get our special lighting effects for our engine nozzles working. So for that, I'm using a product from Adafruit. It's called the Circuit Playground Express. It's a fantastic board that does all kinds of things for you. So I'll cover this more in my separate video on electronics for artists, but quick intro, this has all kinds of sensors on it, buttons, light sensors, sound sensors, IR sensors, etc., position sensors, acceleration sensors. It's got all kinds of NeoPixel LEDs on it built in. It just does fantastic things for you. So we're going to use most of this, well, some of it, for our spaceship in a bottle. But we'll start by using these NeoPixel LEDs on the outside to light up our engine nozzles in the back of the spaceship. It looks like this in our design. Okay, so first, when you plug this into a USB port for power, of the box, it looks like this. And it's kind of hard to see, but you can see the different colors on the NeoPixels. That's its default. All right, now I'm going to go ahead and upload our program. And you'll see how it looks. Okay, now I'm going to dim the lights here. See if you can see this a little better. All right, I think you can see it better now. So it's flickering. And the reason I want it to flicker is because I wanted some drama in this spaceship in a bottle. So I want it to be that the astronaut is maybe running low on fuel. He's using an old vintage CRT to fly his or her spaceship, and maybe having some engine problems. And so it's going to flicker like this. I'm also going to have it change colors kind of randomly every once in a while. So you'll kind of see the flicker. Maybe hard to see on the video, but it is flickering. Now, we're going to 3D print some nozzles that look kind of like this. And each nozzle fits right over the top of one of the NeoPixel CRTs. So it looks like this. And now you've got some nice flickering engine nozzles. There you go. You can see that a little better. Looks like that. So yeah, engine problems, low on fuel, far from home. You get the idea. There's kind of a yellow-orange color. And there's a green color. So you get the idea. It's got some nice flickering going on. All right, so that's the basis of the nozzles for our spaceship. Now we'll also use this Circuit Playground Express to power a bunch of NeoPixels and lights all over the spaceship. We'll run some of those to power our bigger nozzles at the back, which we'll 3D print, and then we'll have some other, what do you want to call it, like mood lighting in different places in the spaceship, and we'll use the Circuit Playground Express to power those NeoPixels also. All right, that's how it looks. So you get the idea. So now we've got our vintage CRT working. We've got a way to simulate the engines working in the back, and we're good to go to the next step. All right, we accomplished a lot today. We got our vintage CRT working, got some space-themed videos on it. We got our Circuit Playground Express fired up with some flickering engine nozzles. So now we're good to go to the next step. We'll come back for the next one. Please like and subscribe. In the next step, we will 3D print and laser cut a bunch of stuff, and we'll also use an acrylic bender to bend some special acrylic pieces to fit in our spaceship. Make sure you come back and watch that. And until we see you again, just make sure to take good care of each other. See you later.